Hi guys, this is Vishal. I'm going to be talking about OpenGL in this video. OpenGL essentially stands for Open Graphics Library, and it is an API which is very powerful. And the main purpose of this API is to render 2D and 3D graphics. OpenGL is also cross-language and cross-platform. What this means is basically in any sort of programming language like Python or JavaScript, there are bindings for which you can use OpenGL and code in that specific language. Also, this OpenGL was essentially written in C, C++, and later the bindings for different programming languages came up. So OpenGL is a very powerful tool, and it accesses your GPU, which is your graphic processing unit, for your computer to make drawings. And your GPU is a very powerful tool as it can do a crazy amount of matrix transformations and calculations of different sorts in a few seconds. So OpenGL can tap into this and use this very effectively. There are also other APIs like Vulkan, which work in a similar fashion. So in this video, we're going to be primarily dealing with the 3D primitives in OpenGL, and there are quite a few primitives that exist as a definition in OpenGL. So as you can see, we have sphere, cube, cone, torus, dodecahedron, octahedron, tetrahedron, icosahedron, and of course the teapot. So we'll be looking into each of these 3D primitives with my implementation, and we can have like a sort of closer look at each of these by changing the values, messing around with the parameters, and we'll get an in-depth feel of what the actual drawing in OpenGL looks like. So the programming environment that I've chosen for this exercise basically is Visual Studio, and it seemed very easy to set the whole thing up and get OpenGL to work on this compared to maybe other IDEs. So essentially, you'll have to download a couple of files, DLL files, and you'll have to add them to your path. And once you do that, you'll be good to go. I will link the procedure to do that and the initialization part in the description. So to begin with, we have the basic C++ stuff, which is including your necessary libraries, your namespace, and here we basically initialize all our variables that we're going to be using, which are going to be like your angles, the radii, side length, etc. And moving down, we have the display function. So this is where our drawing essentially happens. And uh, what's going to happen here is we have, since it's an API, we have very simple function calls. So these function calls vary from wanting to draw a sphere to a cube to any other shape that's supported by this API. So to begin with, we have simple initializations that are mandatory by OpenGL. And this section here essentially is so how much uh, the model or shape that's going to be drawn is translated. So the GL translate is has three parameters: the x, y, and z. So in this case, x and y are set to 0. That means it's not going to be translated in the x or y axis, but it is going to be translated in terms of the depth or how much it's going to be pushed inside or out of the screen. So we'll be dealing with that later. I'll get back to that. But apart from that, we also have the rotate. So GL rotate, it uses different angles x, y, and z. So this essentially moves around the 3D figure that we're drawing. So the 3D figure, which is static, was just a projection onto a 2D surface, and that's not very fun, to be honest. And it doesn't make a lot of sense to view a 3D object in a 2D environment. So this sort of moves it around and gives you a feel of a 3D environment. And so also the scaling is essentially none. It's all going to be true to its scale. So as you can see, all of the X, Y, and Z are set to 1. And so we have the keyboard input in this case. So basically, we're going to be choosing what sort of figure we want to be drawing. So if it's a sphere, a cube, a cone, we choose a number that corresponds to it. So once that is chosen, the functions are called with all the parameters that are going to be entered by you. And once you do that, the shape will be drawn. So it only makes sense for the sphere, cube, and cone and torus to have parameters. So the other shapes do not have any initializations. So let's move on to the actual demonstration. So let me quickly debug and run this. So let's kick it off with the sphere. So we have a tiny sphere here. We can obviously change its dimensions. So let's try doing that. So let's make the radius maybe 4. There we go. So you can see these sort of lines being drawn to represent the wireframe structure. We can actually modify the amount of, or sort of the density of lines that are being drawn. So I'll get back to you on that maybe once we run through all of the shapes. And I'll show you what happens when we change this parameter. So moving on, we can see how the cube looks with a side length of maybe 4. And that's the cube. We have the cone. Let's say base radius of 2, height of 4. So you can see as the cone moves around all its crazy projections onto the different planes. So next we have the torus. We can choose something like 2 and 3. A very interesting shape. Um, also called the donut shape. We can move on to the dodecahedron. So here is where the depth comes in. So the translation and the depth axis is mostly pushing it away inside the screen. We can bring it up further. I'll show you how you do that in a minute. Then we have the octahedron, the tetrahedron, the icosahedron, and finally the teapot. So let's actually try and bring this out further towards the screen. So let's save it and try running it again. So starting off with the dodecahedron, there we can have a much better look at it. So as you can see, it's being pushed further towards the screen. And let's try just one more, maybe, or two more. So let's do icosahedron, and we can also do the teapot. That looks magnificent. So I'll show you the stacks and slices now, how you can change that and what effect it has. So it's initially set to 10. So let me change that to 20. And let's run this. So a couple of quick examples, maybe the clone. Okay, so let's change the dimensions, make it 2, As you can see, the diagram has sort of become more dense. The model, the lines are basically increased, and let's see the octahedron, and to actually see a difference, you can actually look at the sphere with the radius of maybe 4, or let's reduce that. Okay. So as you can see, the lines are more packed, or more densely packed. So OpenGL is a very powerful tool and it's quite easy to use. So you can essentially come up with multiple drawings, animations, 2D, 3D renderings, which might be useful for your understanding, and sort of explore with all the options available. And that'll be all for this video. Thank you guys.